Okay, here we go with problem 6 from the chapter 1 review. So here we are talking about a pyramid in Giza in Egypt, and we are told that the base of the pyramid is approximately square in shape with sides of length 230 meters. So 230 by 230 meters, approximately square, so we're going with that. Measured to the nearest meter. Calculate the upper and lower bounds of the exact area A of the base. Okay, so this is an approximation. The smallest the sides could be would be half of a meter off of this. Okay, so if it said it's measured to nearest meter, 1 meter, you cut that in half, okay, which gives you 0.5 meters, and we're going to subtract it from the side and we're going to add it to the side. So if I subtract that, we get 229.5. Okay, so it could be that. That's the smallest it could be. And the largest it could be is we would add half a meter to both sides. So that would be 230.5 meters. 2 meters. Oops, running out of room. 230.5 meters. Okay, so the smallest area that we could get would be from this square, and the largest area we could get would be from this square. So I would go ahead and square these. So 229.5 squared is equal to, I already did this, I'm just going to write it down. I know you know how to do it on your calculator, 0.25. So that's the smallest area that I could get, 52,670.25. And the largest area I could get would be 230.5 squared, which would be 53,130.25. Okay, we're calling this area, I think they wanted to call it A. So we could say A is going to be greater than or equal to the smallest one, 52,670.25. And the largest it could be, it can't actually equal this because 230.5 would be rounded up to 231, right? So that's why we use the less than symbol, not the less than or equal to, because if the side was actually 230.5, the people who measured it would have rounded it up to 231 if they were going to the nearest meter. All right, so that's why we don't put the equal sign here. And that would be 53,130.25. Okay, so that's the answer to part A. Okay, part B says if you were to try and fit a bunch of football pitches into this square, how many could you fit? And they say that the width of a football pitch has to be between 64 and 75 meters, and the length must be between 100 and 110. So I'm going to just make, for part B here, I'm just going to think about what's the smallest football pitch. And when they say football, they're talking about soccer for Americans. So the smallest it could be is 64 by 100. That's the smallest it could be. And the largest it could be would be 75 by 110. And I'm not going to worry about doing 75 with 100 because that would be in between these two sizes. So we want to find the range of number of pitches that we could fit into the base of this pyramid. And we're just going to look at, well, the most number of football pitches would come from dividing the pyramid up into little tiny football fields, and the smallest number of football pitches would be dividing up the base of the pyramid into these big ones. So we don't care about the 64 by 110 and the 75 by 110 because those are going to be in between sizes. So we care about the littlest and the biggest. All right, so if I multiply this out, the area of this one is going to be 64 times 100, so 6,400. And the area of this one, 75 times 110, gives me 8,250. I did that on my calculator. No, I'm not a human calculator. All right, so now I want what do I want? Find the upper and lower bounds for the number of football pitches that fit into the base area of the Cheops, I hope that's how you say it, pyramid. And what we want to do is we want to look at both of these numbers. Like we want to use these numbers as our pyramid. So if I take the smallest number of pitches that could fit into the pyramid, the smallest number of pitches would be if I took the smallest area of the pyramid and divided it by the largest football pitches. That's going to give me the smallest possible number of football pitches. If I take the littlest pyramid value and divide it by the largest football pitch, that's going to give me the fewest number of football pitches. The most number of football pitches would be if I took the biggest value for the area of the pyramid and divided it by the littlest football pitches. Okay, so to get it's called R, is the number of pitches. That's the letter they give us. So when I set up the ratio, to get the smallest number, again, it's going to take the smallest area and divide it by the biggest area. That's going to get us the smallest number of pitches. And the biggest number of pitches is going to be taking the largest possible area of the pyramid, 53,130.25, and divide it by the smallest football pitches I can make, which are 6,400. Okay, so then we're going to divide those, and let me do this on my calculator because I rounded off. I rounded off my answers to the nearest pitch because the way the book asked it, it said as a number of complete pitches. So I was thinking they didn't want a decimal, but if you look in the back of the book, they asked for a decimal. So, okay, go figure. I don't quite get this book. Okay, so I'm going to do the first one, 52,670.25 divided by 8,250, and I get 6.38. So 6.38 pitches, but it said complete pitches, so I'd round that to 6. And then the other one is 53,130.25 divided by 6,400, and I get 8.30. So if we're doing three significant figures, this is the answer we would get. I think it was asking for a number of complete pitches, and I think the answer should be this. But the book gives us this, which I don't think really matches the question. So I'm a little annoyed with that. So, but that's it. Alrighty. That's problem number 6.